Hi there. In this video we're going to look at finding the volume of different types of pyramid. So we'll briefly just look at explaining why the volume of a pyramid is a third times by the area of the base times by the height, and then we'll look at how we can apply that formula in different contexts. Okay, so first we're going to briefly look at why the volume of a pyramid is a third times by the area of the base times by the height. It seems kind of mysterious. It feels like there's maybe an analogue to triangles somewhere. But just for this, we're going to look at a slightly more intuitive way of sort of justifying why it's a third. Now, this is far from a proof, but we're just going to look at exactly why it might be a third. So what I've got here is we've got a cube, and right in the middle of the cube, I've drawn a point, and then from that point, we've got a pyramid on the bottom, a pyramid on the top. And if you're sort of a little bit creative with your visualization, you can also see a pyramid on this left-hand side, with this square as the base, a pyramid on this right-hand side with this square as the base, and there's a pyramid on the front with this square as the base, and one on the back with that back square as the base. So what that means is, if each of these squares are the base of a pyramid, which all go to the middle, then this cube is made up of 6 identical pyramids. So the cube, or the volume of the cube, is equal to 6 times by the volume of a pyramid. Okay, so, the volume of the cube is the length times by the width times by the height. So the volume of the cube is x cubed, and that's equal to 6 times by the volume of my pyramid. But we've got one little extra step to make. The height of this pyramid isn't the full length of the cube, is it? The height of this pyramid is actually half the height of the cube. So the height of the pyramid h is a half of x. So if we want to show that the volume of the pyramid is a third times by the area of the base times by the area of the height, well, actually, if the 6 pyramids make up a full cube, half the cube, which is x squared times by h, so half a cube is 3 pyramids, which means we're sort of getting slightly closer to what we want to show. So if half of the cube is 3 pyramids, well, half of the cube becomes a prism. We get x squared on the bottom times by the height, and that's 3 pyramids. So that means that 1 pyramid is a third of this. So a third of x squared times by h is 1 pyramid. And the last thing we've got to spot is that this x squared is exactly the area of the base of this pyramid. So that x squared is our area. So we get the pyramid, or the volume of a pyramid, is a third times by the area times by the height. Now again, that's far from a proof, and that's only in the very specific case where we've got a cube. If you are interested in a slightly more rigorous proof, if you've done a little bit of calculus, I know this is based at GCSE, but if you have done a little bit of calculus, a little bit of integration, if you click on the video up here, I don't know what I'm doing, but there will be another video that takes through a more rigorous proof using a little bit of calculus that proves this formula. If you're not interested in that, then just keep watching and we'll look at how we apply this formula, which is what you need for your GCSE. Okay, so on to our first example. Just cut that. Okay, so on to our first example. Here we have a rectangular base pyramid, and the height of the pyramid is 10 centimetres. And the lengths of the rectangle on the bottom are 4 and 3, and we need to find the volume. So again, if we recall that the volume is a third times by the area of the base times by the height, we can work this out quite nicely. So our first step, our general strategy with this, is usually going to be to find the area first if we're not already told it. And in this case, we need to find the area of this rectangle. So the area of the rectangle, now Sometimes it's worth just drawing out the base separately so you can work it out. I don't think we need to on this one because the area of a rectangle, one of the easiest shapes to find the area of, we just do the width times by the length. So we do 4 times by 3, which is 12 centimetres squared. So then to find the volume, we do 1/3 times by this 12 times by the height, which is 10. So let's work that out. Well, 1/3 of 12 is 4, and then times by 10 is 40, and our units of volume are centimetres cubed. Okay, so on to our next example here. So this is a triangular based pyramid, and you'll spot that this triangle on the bottom is a right angle triangle, which means we can work out the area of the base fairly easily. So in this one I am going to draw out the triangle separately just so we can see what's going on. So if we draw this triangle out, it's a right angle triangle, so we'll draw a handy right angle triangle. And then this length here is 5 centimetres, that corresponds to this side here, and then this length here is 6 centimetres. So now hopefully, because we've drawn it flat, something we're used to, we should be able to work out what the area of that is fairly easily. So recall that the area of a triangle is 1/2 times by the base times by the height, because it's half of a rectangle. So we do 1/2 times by the 5. Now the height does have to be the perpendicular height, but because this is a right angle triangle, that length is perpendicular, so we can just use the 6. Now 1/2 of 6 is 3, times by the 5 is 15 centimetres squared. So now my area is 15 centimetres squared, and I can use my formula the same as I did before. So my volume is equal to 1/3 times by the area, which is 15, times by the height, which we're told is 12. Okay, so 1/3 of 15 is 5, and 5 times 12 is 60 centimetres cubed this time. Brilliant. Okay, so on to our third example here. So this one is slightly different because we're asked to find x and we are given the volume. So what we need to do is, as with all these questions we're asked to work backwards, we need to think, how did the person writing this question arrive at this answer of 10 centimetres cubed? And then we can work backwards from there. So if you think back to the previous examples, to get to our answer of volume, we needed to do two things. We needed to find the area A, and then we needed to use V is 1/3 times A times H. Now, I know what H is. I know that H is 6, so I can swap that out straight away. And the thing I can't work out is this X, which means I can't work out the area. So what I need to do is I need to think, okay, if I've done 1/3 times by 6 times by the area, and I've got an answer of 10, what must the area have been? So let's just simplify this down a little bit first. Let's do the 1/3 times by the 6. Well, the 1/3 times by 6 is just 2. So I've got 10 is equal to 2 times by my area, which means my area just has to be 5. For this equation to work, for this formula to be true, the area that they got when they worked out the area of this triangle on the bottom must have been 5. So now we're homing in on the answer a little bit, because now we can find the area, we can work out what the area must have been. Or we work out what x must have been, sorry, to give an area of 5. So again, let's just draw out this triangle. So the triangle here, it's a right angle triangle, it's x and 2. Now the area of a triangle is 1/2 times by the base times by the height. So I'll carry on down here. So area is equal to 1/2 times by base times by height, which is 1/2. Well, the base in this case is x, and the height is 2. And the area we've worked out must have been 5. So I know that the area of 5 is a half times by x times by 2. Again, let's simplify this down slightly. A half times by 2 just gives me 1. So actually, it falls out that x is just equal to 5 centimetres. There we go. So if we're asked to find a length and we're asked to work backwards, again, think through this process. What must they have done to work out the answer? And then work backwards from there. Well done.